This is Matt Carney, EdTech Summer 2023, Intermediate Milestone number 1. My project is a web app, so I'm going to give you some background and then just dive in, show you what I've been working on and some code. Okay, so my project, like I mentioned, is a web app and it's called Grid Vatis. And it is a dynamic line rating educational sandbox. So when we talk about lines here, we're talking about transmission lines for energy. And when we talk about ratings, we're talking about a steady state thermal rating. So there's lots of different criterion and considerations for the operation of safe transmission lines, but one of them is the thermal rating. And so the thermal rating, essentially you have a set temperature, and then you can calculate the current, which is determined by the convected heat loss, radiated heat loss, heat gain from the sun, and the AC resistance of the conductor. And each of those different parts of the equation are influenced by environmental conditions. So ambient temperature, wind speed, wind direction, solar irradiance. So at a high level, if you think about it, right, if you have two different transmission lines, one's in a really cold climate, one's in a really hot climate, the colder ambient temperature is actually to provide cooling to the line, and so you can push more current through it. Okay, so that's the line rating. And there's several different approaches on how the utilities use that line rating for determining how they want to operate their grid. So historically, they would do just a static line rating. So that's a really conservative 99th percentile, looking at over the course of the year, what is the worst case scenario, or what is the combination of conditions that would be the worst case scenario, and we're going to set that as the maximum rating for that line. So that's okay, because it's safe, but you're also missing out on the instances when it isn't at that worst case condition that you could be pushing more current through it. So that's where dynamic line ratings come in. You're actually either looking at advanced numerical weather forecasts, or you might even have some sensors in the field near the transmission line, and you're taking those real-time ratings to feed it into real-time readings from the sensors to feed it in to get a current line rating. So that's all good, but in any situation, if you want to forecast, which is important for grid operations, the line rating, you need to have some sort of forecast of these different environmental conditions. And so your dynamic line rating forecast essentially is a forecast of forecasts, right? And so what I wanted, there's lots of different research and papers on how to make this more accurate, but I wanted to build a web app to build some intuition on this. Okay, so like I gave the example of the different ambient temperature, how that might affect the line rating. But what is that? How about wind speed? How about wind direction? In addition to that, I wanted to investigate how the uncertainty with those weather forecasts impacts the uncertainty with your dynamic line rating forecast. So I think it'll make a little bit more sense when I actually jump into the web app. And also, Vatis is a Latin term used to refer to a prophet, seer, or poet, or someone who can possess the ability to predict in the future. So grid Vatis, to be able to forecast in the future with the grid. Okay, so we'll jump into the DLR calculation. So this was what I was working on predominantly for the first week. This is from the IEEE 738/2006. It's a first principle equation. Nothing too crazy here. A little tedious, just essentially transcribing all these different components. I made a DLR class, and so I think what's noteworthy here is you can make an instance of this class, and the inputs are wind speed, wind angle, ambient temperature, and heat flux. Then you call the ampacity method, and it will return the ampacity. Okay, now, and that's going to be used again and again and again, because like I mentioned before, for all these different, we're going to be running a whole bunch of different scenarios and simulations to calculate this to calculate this line rating. And so then we'll be using that class or a bunch of instances from that class, a bunch. Okay, now to the web app. So I am using Streamlit. So far it's been pretty good. I mean, a little bit you know, you're a little bit limited in what you can develop right out of the box, but it's been pretty easy. So I've been pretty happy with it so far. This is the homepage. A lot of this is placeholders for the time being, but I'm going to have, so the homepage, this is going to be the benefits of the dynamic line rating, like I was talking about before, like, really how you can still operate the grid safely when you're using this more real-time measurement of the different or forecast of the line ratings. This is also where a lot of the micro learning and the micro lessons are going to be. We'll get back to so this sensitivity page is what I've been working on mostly, but I'm going to come back to that in a sec. And then this is the placeholder for the scenarios, and then this is the references, once again, a placeholder. So I've been predominantly working on this tab throughout week 2. And actually the main component was developing this 2D contour visual. So in one of my papers that I saw, I really liked this visual. So you can see here, so I guess it'd be like a time series probability, but where you have time on the x-axis or any sort of horizon, and then you have your variable, and you can see just the different, the probability as it changes over time. So like here, right, you can see that, if you're thinking about like a weather forecast, like there's always going to be a little bit of uncertainty with it, but as your time horizon extends into the future, that uncertainty becomes much greater. So you can see here, right, it's highly likely that this temperature is going to be 27 degrees, but you forecast out, thinking about what the temperature is going to be, 13 days later, it's going to be much more uniform. So I was able to build that visual or something resembling it with Plotly, with the 2D contour. A little bit challenging to get it to do exactly what I want, and I still want to make some tweaks, but overall it seems to be working. Another piece with this is that I had to think through is, okay, so how am I going to add what I'm calling the temporal decay from the weather forecast? So if you have an initial distribution, so let's just say it's a normal distribution at t equals 0, and then as you're moving through your forecast horizon, that's going to transition from a normal distribution, an initial normal distribution, to uniform. And I was trying to actually just determine those percentiles numerically, and was running into some issues, and so I ended up just running a bunch of different Monte Carlo simulations. So what I have here on the back end is at t equals 0. It's your initial distribution, which I'm setting as normal now. Could be Weibull or any other initial distribution. And then so I'm collecting 10,000 samples, making 10,000 samples from that distribution, and then for each time step, I'm sampling at a different percentage between that initial normal distribution and a uniform distribution. So so I have 10,000 samples, and then as this time progresses, so at the halfway through the time horizon, it would be taking 5,000 samples from a normal distribution, 5,000 samples from a uniform distribution. It's combining them into that unique distribution, and then from there I can calculate the statistics that's driving these different contours. And then so obviously at the end here, it's just almost purely uniform. So that took up a bit of time this week to figure out how to make this visual work. But the way that this layout is going to be, so here's the actual forecast of the dynamic line rating, and then for each of those weather forecasts, it's going to have its own visual, and then different controls that the user can change. So here we have that. So here we're looking at the wind velocity, and so you can see these aren't feeding into this dynamic line rating visual now, but what you would see is, okay, as I increase this velocity, how is this dynamic line rating changing? And then you can also change the standard deviation, right? So we're just increasing it here, and once again, the point is for the user to say, okay, maybe if I have two different wind forecasts, but I'm much more certain on one versus the other, how does that ultimately impact the dynamic line rating forecast? And so will be very similar for the other environmental variables. So instead of wind velocity, we have wind direction, temperature, and the solar irradiance. Each of these are going to have their own set of sliders that the user can use, the user can interact with. And so this is really the core of the web app right here. There are some changes I want to make. I want to see if I could actually kind of collapse these different weather forecasts. That way you could, or maybe just freeze this one. So that way you could, as you're scrolling, it's a little bit easier to navigate, and you can see, if I want to change the temperature forecast, I want to actually be able to see without having to scroll back up how that impacts the DLR forecast. I want to make some more tweaks to these visuals as well. Make it not quite not have as the scale be not as I guess it'd be like not as have like kind of bend these together a little bit so it's not as granular. I'm gonna double check to see whatever changes I wanted to make. You can see here that I need to do something. So these are all generated randomly. I need to set the random seed. So if I'm adjusting the velocity for the wind velocity, I don't want the wind direction forecast to change itself. So that's the core of what I've been working on so far. Up next, so these scenarios. So this is really like what I think of as like the sandbox. So the user can come in here, they can change all the different parameters, and they can under visualize or in real time see how that would change the DLR forecast, both the value and the uncertainty. And then this tab is going to be some pre-canned scenarios. So we'll take like cold and windy, and sunny and not windy, and we'll have this listed out, those those scenarios kind of listed out here, and it'll be some sort of matching. So some sort of like a question or a quiz based based tab where you're trying to match the high line rating with the low based on these different scenarios, or some sort of more traditional sort of quiz based or knowledge check, I guess I should say, on here with some pre-canned scenarios. And then kind of going back up to here, the benefits of DLR. I already talked about that a little bit, just sort of driving home why this is important. There's a whole bunch from an asset management perspective, from a cost perspective, from a grid operations perspective, on why the DLR is an important philosophy for utilities to embrace. I think that's it, and thanks for watching, and have a nice day.